This thing is still running, I think. Yep, I'm frame 27. Let's see what happens here. I believe this is it here. Taking 10-second shots. Next one comes up. The auto guider's settling again. All right. Yep, see that move? That sucker is really hauling. Holy cow. What's on the cards tonight? Oh, asteroid, near Earth asteroid 3122, or asteroid Florence. I decided to make a quick run on it, and I slewed over to it and was watching and taking some 2-second shots, and it is moving so fast it's actually streaking at 10 seconds here. In fact, I'm going to zoom in on it a little bit so you can look at it. Hang on a second, we'll get over there. This is the asteroid. You'll watch it move relative to the two stars every time I take a 10-second download here. Downloading, and there it moved. It's 8.8 magnitude right now, and it's going to be flying closest approaches tonight, actually tomorrow morning. So I thought I'd give it a shot here. Yep, see that move? Boom, boom. It's actually 10 seconds is actually too long. It's doing a little bit of streaking, even though I'm guiding on a star right now. I may actually have to shorten this up a bit. It's really moving. I'll put my cursor on there. This next download, it'll show the movement. See how much that moved off the cursor, off the arrow there? It's running quite quickly. I'll put the arrow back on it again. Oh, moved again. See, I'm taking 10-second shots here. It's bright too. But it is moving. Zoom back out a little bit here. I'll put the cursor on it and you'll be able to see it move. Boom, just moved. I may actually have to shorten up the exposures on this thing. It may actually move out of the field of view before I run this sequence down. I'm going to leave that arrow right there so you can watch how it moves every 10 seconds or so. My auto guider's settling down before it takes the next one. Got a little bit of guiding error here. Not bad, but you can see it's working on it. It is moving. Got a little deck drift. I wonder why that's happening. Oh, I'm looking east. I might be heavy on the scope side instead of the weight side. Let's bounce around a little bit. It's only one plus or minus a pixel or so. That's not bad. This asteroid, when I started the sequence, which have been, what am I on frame now? 360 seconds ago. It was over here, so it's moved a lot. Is this Cornell? Mark. Yeah, probably. So we're following, I've got the data up here, and near-Earth asteroid 3122. It's also called Florence. And it's moving quite quickly, actually. Faster than the comet shots that I did. Look at how much that moved. It must have had to settle for a little bit. It jumped from here to there. It was waiting because my scope was waiting to, or the sequence pro was waiting for my auto guider to settle before we take the next one. So there was quite a bit of time in between those two. Yep. I bet you it didn't take a shot for over a minute. Interesting. What if I can turn that settling off? Otherwise, it's going to be a pretty jumpy video. Yeah, auto guider is not. See, it's got to get down below 0.5 before it'll allow me to take another shot here. The auto guider is really bouncing around. By the time it takes another shot, it's going to jump a bunch. I'm waiting for this to settle. I'm thinking maybe I'll turn this off. It's not settling. Let me just check the threshold on this. Yeah, it won't settle until it gets less than a half a pixel. I'm going to up that to 0.7. There we go. That way it should take images a little more quickly. Yeah, I have this set up so that the auto guider has to be plus or minus or less than a half pixel off before it'll take another image. So I just upped the settling time to 0.7, 7/10 of a pixel, which is actually less than a half arc second. But this thing has moved from over here to over here. Yeah, I mean, you could see it moving every frame here. 10-second frames here. I'm going to slide this over so we can watch it come into the field of view. Yep. It's really moving. I'm thinking I might even just shorten up the exposure times here. I'm doing 10 seconds because I thought it might be dim, but it is pretty easy to see. I've got the histogram stretched on it too, so if I go out to full dynamic range, it's not real bright, but this was just so you can see it easier. But you can just sit here and watch it move. Yeah. I mean, each frame is about 10 seconds long, and you figure 15 seconds for download total, so every 15 seconds it's moving in the frame. Don't know. I have to look that up. Let me see if I can get the data on that here. Let's see here. It's changing all the time, so deck rate in arc seconds is 0.38. and RA is minus 0.09, so 0.38 arc seconds, and I believe that's per second. Let me see if that, yep, it's moving almost 0.4 arc seconds per second in deck right now. There it is. For those that just joined, I'm downloading, taking 10-second shots continuously of this asteroid, and it is moving a lot. So I just checked the data. It's about 0.4 arc seconds per second, and you can watch it move every time. Every time this completes an integration, it says downloading. A new frame comes up. I'll put the cursor right on top of it here. In terms of miles per hour or kilometers per hour, I don't know that data, Mark. Just can tell you what the angular speed is right now. And you can just sit there and this will go out of my field of view, I think, before my sequence runs. I'm on frame 58 at 240. If the resolution of the YouTube is not high, go down to the bottom of the YouTube channel, on the right-hand side where there's the resolution. It's probably poor. Click on it and set it to 1080p. It'll be sharp. The screen will be sharp. On the little gearbox or the gear circle, you can select 1080p, and the screen should be sharp again. Because a lot of them default to 480p, and people wondered why it looks so crappy. Well, that's because it has to be changed on your end. I'm actually broadcasting at 1440p, I think. No, I might be broadcasting at 1080p. But if the screen looks fuzzy to you, just change that in the little gearbox. Change it up to 1080p, and it should sharpen up for you. Okay. Okay, let me. Oh, yep. So we're looking at this real time. I'm thinking I should maybe do this a little faster. But 10 seconds isn't too bad. That's the asteroid. And it is moving. Yep, there you go. 1080p is good. Yep. I'm broadcasting at 1080p, but for some reason when people come in on the YouTube channel, they look at it and they're actually running 480p, and it's really dim, fuzzy. I've gotten feedback. How come it's so fuzzy? Well, come to find out at your end, you have to change it to 1080p in order to get it to display properly. But once you do that, it should be really clear. I don't know why it doesn't automatically update it on the viewer side, because that's what I'm broadcasting at. So again, if the screen is fuzzy, use the little gear icon at the bottom right of YouTube and set it to 1080p, and the screen will be nice resolution for you. Wonder why my pulse guiding has stopped. No, that was just a glitch. Okay. Anyways, this is asteroid 3122. Feel free to type into the text chat and I'll answer any questions. This is the asteroid I'm tracking right now, which I just typed into the text chat so that people coming in hopefully will see that. And I'm just running 10-second exposures, and I got the sequence set up for 240 of them. So we'll see how that works out. I could actually run this faster at about 5 seconds, and it would work fine. I'll put the arrow back on there, and you can see it move on each frame as it downloads. Who else is here besides Mark? There's 2 other people in here. You can type in the live chat if you don't mind. I should put the crosshairs up. They'll let me do that. That way you can watch it relative to that. No, I'm not going to put those up. That's only for the focus. Well, if I'm not careful, it's going to go out of my field of view up here. Yep, it's moving. 4.4 million miles this in the morning, around 8 a.m. It's a little ways out there, 4.4 million. But it's in our neighborhood. It's going to happen tomorrow. Oh, look at that. Had a satellite or something fly through that frame. That's kind of why I wanted to grab it tonight. Because it's clear, it happens to be clear here, which is kind of rare. And it's going to be close approach in the next, 10 hours or whatever. And why not? The moon's bright. This will be fun just to capture this stuff. I'll make a little video of this. And this is the asteroid for those that just joined. If you watch stick around for a minute, you'll watch it move 6 times because I'm taking 10-second shots. And you'll see it move in the field of view. Yep. Little bump there. If you have any questions, feel free to type into the text chat. Be nice if I could put an overlay on this so you can keep an eye on it. Yes, Gary, that is great. Gary remembers the old times of running film. I do also running a 30-minute or an hour exposure, manually guiding on Ektachrome 400 through my 8-inch or my 12-inch. You get a satellite running right through the field of view and ruin it. Well, wouldn't ruin it, but it obviously would interfere with what your intent was. Oh, and lots of other things that can go wrong as well. Yeah. See, I haven't moved the cursor. At least I don't think I haven't. You can see how much it's moved just in a minute or so here. I think I'm still tracking here. Yeah, plus or minus a pixel, so we're good. You know, Gary, I'm so glad I got this system up and running this last year, or 10 months ago, 8 months ago. This has been really fun. I haven't had this much fun doing astrophotography ever. You see how focus lock is doing here. Yep, yep, we're green on the focus. Good shape there. So since I started this run, it has moved from here to there. And that's in 107 frames at 10 seconds each. So a little over 1,100 seconds almost. It's moved about, well, let's see here. It's moved about, oh hell, a third of the field of view across in 1,100 seconds or so. Mm-hmm. Yeah, it finally got to the price point that I could afford. It only took 20 years. Because I was trying to do this automation 20 years ago. But I couldn't afford the good stuff back then. Yeah, this is the scale of my camera, 0.49 arc seconds per pixel, about a half an arc second per pixel. And basically the guider's staying plus or minus, like it shows here, plus or minus a pixel or less. And in fact, the RMS in arc seconds is 0.41. And it's less than an arc second error I'm seeing in RA. And that could be just seeing, for that matter. Let's see, 240 frames. I put that in a video. That'll be about 6 seconds. No, let's see. It'll be about 8 seconds. Well, it's because that's how they make the chips. Actually, the big guys do. they have these massive 4x4 chips, and they put them in a circular array, like 10 of them or whatever, to get a giant field of view. Those are multi-million-dollar systems. Us mere mortals just have to deal with what we can. Oh, I do not want this to warm up when I complete. Shut that off. Because I got other things I want to play around with tonight. It's kind of nice it gets dark earlier now. I got this up and running about, I don't know, half hour ago, 45 minutes ago. I really don't want to troll them. I don't care about them, Mark. They're a waste of my time. There's a whole category of people that are just so sure of themselves that they ignore any evidence to the contrary. And the only way I troll them, if they come into the NASA things and all that, I just tell them physics. You can't hide from it. Go take a course. Sorry if I'm crunching here. I get the munchies when I'm doing this stuff. Exactly. Only took me, I dinked around out there for about 20 minutes only because I wanted to check the parafocal of the two cameras as far as focus is concerned. Then I just walked back in here, connected the laptop, and slewed to the asteroid, and it was in the field of view. And while I was sitting there looking at it, it was off just a little bit to the right, so I said, oh, okay, I have to move the scope a little bit to put it in the left because I figured out which direction it was going so I could start the sequence and not lose it out of the field of view right away. This thing is pointing great. I synced on Arcturus, which is over in the west, and I flew all the way over this thing, and it's only 30 degrees off the horizon in the east. It was right in the field of view, and it is fun. I'm tempted to take it up to Great Lakes Stargaze or Boone this fall, and for a week, if the weather was going to be good for at least 4 nights, and use that dark sky site for some stuff. My sky's, kind of like yours, not so great, but better than the suburbs, of course. But I have the cursor on the asteroid right now for whoever just joined, and you'll see it moving every time a frame comes down. Oh, Gary, I didn't email the guys on our little email chain about that I'm doing this, so they don't even know. Most of them aren't even on Facebook, so they wouldn't know anyways. What I should do is get my webcam up, put it in the corner of the YouTube so you can see me sitting here munching peanuts and being comfortable. This is the only way to fly, man. I'll tell you that right now. Oh man, I remember freezing my tush off back in the 70s doing astrophotography in the winter. Man. I like this software I'm using, Sequence Generator Pro. I still haven't gotten the plate solving working quite right. I'm going to need that if I want to start running my 20 galaxies per night program for looking for supernova. I still have to get that working. The idea there is to slew to the field of view, have the plate solver take a picture, identify the galaxy, and then center it. Oh, that'd be awesome, Gary. I didn't have any time to do any nighttime viewing during that week. I spent 4 days driving, 2 days to get to where we're going to go, and 2 days to get back. Boy, I'll tell you what, driving that big RV, 2,400 miles, and was really taxing on me. But we had a goal. I had a goal to get the family to their first eclipse. And it was successful, so that's all I cared about. Now see where my cursor is for whoever joined. It has moved in the last, I'd say, 6-8 frames from where the cursor is to the object that's right next to it here. I'll move my cursor to it now. That is the asteroid. The next download will move it again. Yep, so you just jumped over. It's moving quite quickly. The data I had on it's moving almost 0.4 arc seconds per second. If you have any questions, feel free to type in the text chat. See if I can put some other marker on here. I don't think I'm going to get my 240 frames in before this. No, I might. I only got 80 left to go. Then I'm going to... That'll probably be good enough. I got 200. I'll have 240 frames. Maybe I'll move it back down to the lower corner and take another set. I thought it'd be kind of fun just to watch this live. Yeah, no problem, Dan and Shannon. I figured it'd be fun to kind of track this asteroid as it's whizzing by us here. I started this sequence. It was down here where my cursor is, and in that 163 frames, it's moved from there to there. Each frame is 10 seconds long, so that gives you an idea how much it's moved. Oh, Dan, I do this for free. It's no big deal. It's fun. Besides, get people interested in doing, answering or asking questions, and sometimes people in the text chat will answer. And we've had some good sessions doing this live. It's been a while. It's been over a month since I've done a live session, at least. And sometimes when I do these live sessions, I'm just taking a 4-hour sequence of a galaxy. I start it up. I put a little note over there. This is what we're taking pictures of. This is how long it's going to be. And oh, by the way, I'm taking a nap. So, sometimes I'll start this up and go 4-hour sequence and go to bed. That's how automated it is. I don't even have to watch it. I hadn't planned on it, Gary. I could. Okay, hopefully I won't melt your brain, Mark. But Gary, yeah, I could. I could go through the calculations. I actually wrote celestial mechanics software in 1975 when I was working at Michigan State for calculating the orbits of the planets and the moon. And I built that software for the purposes of the Nat Sci department so that they could use it for their one of their Nat Sci classes, where the students would use my software to print out a chart from, of, let's say, Mars over, let's say, 1 year at increments of a day or a week, whatever they wanted to. It would print out the RA and DEC, the altitude and azimuth if you were at a particular time in a night in your longitude and latitude, etc. It would do all that. And then they would take that data and go and pull out a piece of graph paper and draw it. So they could draw like the retrograde motion of Mars and things like that. So yeah, I've been in this hobby a long time. I actually was minoring at astrophysics at Michigan State. They actually hired me to do some stuff both in software and also spectroscopy there at Michigan State for a year. They actually paid me to do that. That was fun, and some astrophotography. It's 40. Let me think about this. It's four. I think it's 43 by 26 arc minutes. I had those numbers here somewhere. Hang on a second. I have it on this. No, I don't have it. Hang on. I'll have the exact data here in a second. Let me minimize this. I got to pull up my main computer, go to Documents, and 10-inch imaging field of view, data. Here we go. I'm sorry, it's 23.6 by 15.7 in physical size. The field of view was, where did I have that? Where did I have that? Oh, here we go. 40 by 27. 40.2 by 27 arc minutes in this configuration with this 10-inch. Okay? Yeah, it's an APS-C size chip, kind of what you'd have um, in a Canon T3i, or that's the size. It's 40 arc minutes by 20 whatever I had on there. Of course, that changes depending on what scope you put it on, as far as the field of view is concerned. This sucker's up here now. The only thing exciting about this is the fact that we can record its movement so easily. Otherwise, this object's pretty boring. Well, I built this building in 1984, so this observatory's been in place for 33 years. I've had 4 different scopes in it. 4, 1, 2, 3, 4. Actually 5. Yeah, I got a place up 170 miles north of me, which has much darker skies. I've got a building there as well. It's not an observatory, but all the equipment can be rolled out and used pretty easily. But this one's in my backyard. And the observatory is actually about 150 feet away outside, and I'm sitting in my den. Good night, Gary. Yeah, I'm actually a systems analyst for my. Oh, very good, Shannon. I'm a systems guy at Ford Motor Company, but I've been a amateur astronomer longer than that. That's too funny, Daniel. Live from Northern Cross Observatory, asteroid Florence. And it keeps moving. There it is again. I'll put my cursor back on it again. Well, I'll tell you what, Daniel. When we get over 100 people watching live, I'll think maybe there's something going on. uh, I'm not worried about it. This is for educational purposes, anyways. I like to share what we're doing, and people ask questions, and an opportunity for people to learn what's going on, about the equipment, or like, Shannon's been asking questions about the asteroid and distances and other things. So it's I consider this a public outreach type thing. I just don't advertise it much. I put it on the one Facebook group, but sometimes on the other one, the telescope one. It's fun. Besides, when I'm taking a 2-hour exposure of some galaxy, I get kind of bored sitting here if I'm not sleeping. But usually, if I'm going to take a long exposure of something, I'll set the sequence up. I won't even broadcast. I'll be going to bed because I have to work the next day, which I do have to do tomorrow. But it's only 10:15 here right now, so I'm good. And I don't have to actually drive in tomorrow, which is good. It saves me 3 hours of driving tomorrow. Hi, Alan. Welcome. I'm just imaging a little asteroid that is going to be at closest approach here in the next 8-10 hours. So it's moving quite quickly. Closest approach to us, which is 4.4 million miles. And so relative to the background sky, it moves quite a bit. And to give you an idea, when I started this sequence, it was over right about here. And we're about, let's see here, how long have I been running this? This thing's been running for 54 minutes. So in 54 minutes, it's moved from here to there. So that would be probably about 30 arc minutes. It's moved. It's about half the field of view across. I could do the I could measure that tomorrow when I look at the beginning and starting end. As long as I got the times on the files, I know what the timing is for each file that was generated. All right, Alan, take care. So let's see here. I've only got three and a half minutes left on this sequence. I may start another one right here, and we'll make that. I'm going to change that to 5-second exposures, and I'm going to take another 240 of those, and we'll turn that one on right now. So it'll go right into this one here, and we're going to set this to ELF suffix, and actually I'm going to make that 480. Actually, no, I'm not going to do that quite yet. I want to recenter this thing. I've got a one-shot color camera, so photometry is not real accurate with it. If I had a monochrome CCD, I could, and I'm contemplating getting one for exactly that purpose. Since the system's only about 9 months old, most of it's been tuning in the last first 4 or 5 months. Then I was doing some testing on, quality of everything using this one-shot color camera I've got. But I do plan on getting a monochrome so I can do some photometry and astrometry work. And I'll probably get that before Christmas. I just haven't decided which one to get. I mean, I could probably do some estimates. I'll run through the software that I can use to do relative magnitudes on the relative to the stars and maybe get something. I don't know if it'd be any more accurate than a half a mag or not, but we'll see. So before I actually start the second sequence up, I'm going to reposition this thing back down in this corner, and I'll start the sequence over again. Except I don't think I'll take 10-second shots. Let me look what this looks like with. I mean, it's still very visible in the full range, so I'm just going to reposition. The other thing I should do, and I could try that. Actually, this might be a good night to try it. Is to take the RAN deck rates off of the Sky software I have and actually plug them into my guiding system to see if I could just track right on the asteroid directly, and it'll always stay centered and the stars will move. I might even try that here. It would take me some time to set it up, but might be something worth trying. Because that is something I wanted to be able to do with the comets in the future too. In the past, I've just guided on a star and let it run through, and then I do stacking in the PixInsight because it allows you to stack the comet. So only got another 8 exposures to go, and then this sequence will be done. And I want to make sure. And then we'll move it real quick. So that's where the asteroid is right now. Got 3 more frames to go after this one. Then I'm gonna see if we can get that centered, and maybe let's look at that. Turn this up again. Tools. Comet tracking. Take a look at it. Yeah, I wonder if I can make that work. Let's pull that data up. We'll do that right now. That data is right here. IRA rate is this. Yep, my sequence just finished. So let me verify we're all done there. I got to make sure it's not heating the camera up. Yeah, good. All right, so I turned that off. We're good there. I want to dismiss it. And we're still good with the camera, still on, cooled. Okay, good. So now what I want to do is take this data that I have here. I'll move that over here for a second. Pull this up here and translate it over to this one. So we're at minus 0.0975, and this one is at 0.3809, and that's arc seconds per hour. I have to change that. All right. Okay, I'll have to calculate that out. Give me a minute here. All right, so we're at 0.3809 times 60 times 60. So 1,300 arc seconds per hour. Is that correct? I would understand. It's arc seconds per hour. These points are arc seconds per second. 60. Yep. Well, let's see. We'll put that in the deck. It's really moving too far. And then this one is minus 0.0975 times 60 times 60. Oops, clear. Minus 0.0975 times 3,600. That is 351. 351. Okay. Enable. Let's see what that does. Is it going to do anything here? Okay. So let me do that. Select the imaging camera. Yep. So let me center this guy, which is right there. turn off the auto guider. Just stopped. Good. And let me go up here. Start this up. And then let me move this guy. That's where it's at there. Let's move it down here. Where's this? There we go. Wrong way. Let's move this way. Oh, that's right. I was going to put it in the center. We'll see if that works. Put that back here. There it is. I believe that's it. Let me verify this. It should move. Yeah, that's it. All right, let's go back here a little bit. All right, I'm going to stick it right there. That should be good. All right. And this guy. Enable it. Let's see how this works. Let's go 5 seconds. Start it up. See if we can watch it move. Increase this guy. Watch it. See if I'm actually tracking on that. Okay, let me turn this off for a second. Pick guide star. Make sure we got a guide star. Let me turn that on. Yeah, okay, got a guide star. I think I want to pick this one though. Take a look at that. Doesn't have a good signal noise. This one's better. That might be a hot pixel, as a matter of fact. Let me pick this one and see what it does here. Start that. Start on this. Set. Okay. It is increasing. So it is drifting. All right. Take a look at this. Where we're at here. I think I'm doing the training on this. It's the first chance. Well, it's the first chance I've tried using this, so it's I think it's using that to figure out the tracking rate. This guy is moving. Oh, well, that's part of the boring stuff that I do. I haven't tried doing this before, so this is part of the learning curve right now. Training elapsed. time, 106 seconds. Use the adjust lock position controls to center the, well, what am I supposed to center? All right. All right, I don't know what I'm doing here. Hang on a second here. Oh, I like trying to figure stuff out too. This guy isn't moving now, though. I don't think. We may have it trained. All right, let's stop that. All right. Now let's close this. And let's see what it does. I'm going to put this right here. Take a 5-second shot. We're just dinking around here. This is the asteroid that's here. What I need to do is monitor its movement relative to, let's say, this bright star down here. Well, you know, I'm not sure we're tracking this. Let me stop this and restart it again. Let's take one and see. I'm not sure I'm getting an update on here. Okay, I am tracking the asteroid now because all the star field is moving. So we are tracking actually at the prescribed rate. So it's staying here, and the stars are moving to the left. I just saw them move after 10 seconds. So we got that working. We've actually tracking relative to its I'm actually tracking at the rate that the asteroid is moving, because if you notice, it's staying relative to this crosshair. It's staying right here, while these stars are all moving to the left. So we are tracking now. We trained it well enough that it's going to track on that. So I can actually now turn this off. And the scope is actually tracking now. PhD2 is now tracking at the rate of this asteroid. So this entire field of view is going to move. So I don't even have to move this now. I can now do this in a different way. And that's actually pretty cool. So I'm going to run this. Let me see how far I got to go till meridian flip. I'm power angles. I got an hour and 20 minutes before I hit meridian. I can go about 2 hours over. Yeah, I can go 3 hours before I go to my limit. So I'm in good shape there. So we can run this for a while and make another series. And I'm going to drop this to 5 seconds each. And yeah, 5 seconds here. And we're going to do this. Let me stop that. Do a sequence reset. Yes. I can turn this one off. Good. We got this one on. And now we will be able to watch the field of view move to the left on this screen while this asteroid stays pretty much right here. We've got it tracking at the asteroid rate. This is very cool because I hadn't even tried this before, but I wanted to be able to do it. So this will be interesting. So let's start this sequence up now. So what we're going to see now is this is going to basically stay right here. This object is the asteroid. It's going to stay right here in the field of view. And yeah, the focus lock's going to give me a hard time. I'm going to shut this down. Stop. Hopefully I didn't mess up my focus here. 3095. Hello. Something's going on here. This will be interesting to see if this actually is working now. I noticed this guy just went off the chart on me, which I would expect. I'm going to have to look at this guy as it's downloading images here. No, this is not working. I have to turn this off. Another piece of data I got to do. Focus lock is this. This should be off. I did not turn this off, didn't I? Yeah. I'm going to disconnect this. This is not taking images right now. It's waiting for the autoguider to settle. So now I have to go and turn that off. Pause. Resume. Stop. Okay. We have to stop the sequence here because something is not. Okay. Let's start this back up again. I want to see where I'm at. The two pieces of software are fighting each other right now because the parameters aren't set up to handle it right. So my focus went out to lunch on me. All right. Yep. Almost had it there. It was working with the frame and focus because the autoguider and the focuser were not doing anything at that time. The autoguider was PhD was tracking correctly, but the so now I gotta fix this back up here. Let me go back here. Let's go to here and comet tracking, and let's disable this for the moment. All right, and close that. Go back here where I don't have guide star. This is my object. I'm going to move this now. 2 seconds. Okay, and we're going to move it. Do I have a guide star in here yet? Yeah, there's one. All right. Let's start guiding on this guy. And let's close that. Let's go back to focus lock. We got to get our focus back. Connect all. Start. And let it focus it again. This should come back into focus. It was tracking at the asteroid rate, Shannon. The problem was the focus lock started having a problem because it needs to look at the. I needed to turn that focus lock off before I started that process. Because focus lock would change the since the star was going out of the field of view, it was trying to focus on nothing. So right now I'm just trying to get this back to a decent focus. And once it loses its focus on the tracking software, it doesn't know what to do with it. So let me look at this here, 3493. These are coming in back into good resolution now. All right. We're in the yellow. We're now in the green. We're in good shape for the focus now. Need to turn that thing off. So this software right here is used to focus on the guide star. In other words, you're using the guide star for tracking, but I'm also using it to keep a focus because the two cameras are parfocal. So if I'm in focus with the guide star, a camera, I'm also in focus with the main camera. So that's how I continue to do a real-time focusing over the night. In fact, if I look at this, it's at 3540. We started tonight at 3640. So the temperature's been dropping. It's now 7 degrees out there, Celsius. And so there's been a 150 count change since I started an hour and a half ago. So this is why I use that, is to keep the focus of the cameras good. Obviously, they have to be parfocal for this to work, and I've kind of tweaked them pretty good so they are. So we're now tracking on regular sidereal rate. And I think we can try this again. This is our asteroid, so let me try this again, but this time I'm going to disconnect focus lock. Stop it. And now we will go to the auto guide of PhD 2. And we'll go here. Go here to comet tracking. And let's enable it. Okay, we've already done the rate. We've already done the training. Not sure it's going to do this. All right, let's start the rate training again. Can't get that to tell me what else I'm supposed to center what. Lock controls. Still have the rates. It's in pixels per hour. Okay. We'll do a set on that and stop the training. So we should be active now. See what it does here. Alright, select the guide star and start guiding. Alright. See what happens. I'm going to watch this for a minute, see what it does. Or where did I put it? Did I put it down here? No, it's right here. Pretty sure this is it. Let's up this to 10 seconds. We'll verify it. Yep. All right, we're tracking correctly now. That's interesting how it's using a guide star that's actually moving and compensating relative to the offsets we just gave in. That's interesting. Wonder how they're doing that. I'll have to look into that. So let's start our sequence now. See what happens. Yeah, I saw him move too. That's why I was kind of curious. All right, I'm taking shots now at 5 seconds apiece. We're going to up the histogram here so I can see it a little better. This guy should be sitting still now, relatively, and these should be moving. So I'm going to focus on this big bright star here and see if it moves. We're taking 5-second shots now. So is it moving or is this guy moving? Yeah, I'm trying to figure out how it's doing that. Because the guide camera's only it's got a much smaller field of view. I could understand it if the guide camera is being used, but if I run out of field of view on it relative to the asteroid, that means that this guide star I'm using is tracking across the chip, right? And it may be tracking across the chip now with this guide star. And that guide star may disappear off of this chip through this sequence, depending on where it was on the chip to start with. So this is what I think the PhD2 is doing. It is tracking that guide star, but because it's not at the sidereal rate, it's actually tracking it across the guide camera's chip and staying with it and compensating according to the RA and DEC we put in there in order to keep the asteroid centered. But if it runs off the chip, we're going to run out of a guide star. That's my point. We'll have to see. I need to take a quick break, a little restroom break, and I'll be right back. Okay. Well, it appears that it is not tracking it because I put this cursor on there and it has moved. So let me see what's going on here. Oh, yep. We lost the guide star. Yep, went off the chip. That's why. Okay, so let me stop it and refresh on this. These are hot pixels, I think. Yeah. I think these are hot pixels. I don't think I can use these. Should be hot pixels. We're down. Cool down. The dark frame should be working. Let me stop this. Go to this one here. Oh, these are hot pixels. Pretty sure those are hot pixels. Let me try this again. Start on that one again. Sequence is complete. No, it isn't. Dismiss. Why did it stop? Interesting. Don't know why it stopped. Resume. Store. No, this is not working right. More to learn about this. Stop that. Let's pick this one. Start it again. Nope, I did an auto select. Dismiss. Oh, man, what are you doing to me here? Let's disable this. Disable. I think I'm running into the problem I was describing there, that this is getting out of the range. It's automatically starting a guide for some reason. Sequence aborted again. Alright, let's stop. Let's start this up again. Resume. Guide. Resume. Let me see what this is doing here. Oh, this is part of the debugging. I mean, we're trying a new feature that I haven't tried before, and that is guiding on the asteroid. And it worked for a little while. Something interrupted the process, and I haven't figured that one out yet. I haven't figured that out. Let me see what the auto guide is doing here. Yeah, we're just guiding on the star now because I disabled the rate change. I'll have to mess with that some more. See if I can learn what the peculiarities are. Yeah, we're back on regular star tracking now instead of the comet or the asteroid, because it's going to move each time here. While this is going, let me do some reading on that. Let's see here. Index. Yeah, see, it's doing exactly what I suggested. That it's guiding. It's if you can't guide on the comet itself, the idea is to guide on an ordinary star, but to gradually shift the lock position to match the comet's motion for tracking rate. But the problem is this star will move off the guide scope's chip, and so we'll lose that. I think that's what happened there. Let me do some reading on here. What? Yep, we just lost the star. I don't know why. I wonder if I got some clouds coming over. I think I have some clouds coming over. Let me go check. Or it just went off to Never Neverland. This thing spiked on me. I think the scope moved. That happens from time to time. Not sure why. Let's stop this. And let's go back to just monitoring. Let me pause the sequence. Abort the current sequence. Quits immediately. Okay. And let me see if I can get a guide star back in here. Let's do this. Let's start this. I want to see if this is being extinguished by clouds, possibly. I might have to go outside and take a look. See what this looks like here. Now it's moving. So I'm going to move this scope. Of course I moved it the wrong way. Alright, let me see if I got a guide star in here now. Boy, the signal noise is pretty bad. Let me go check the sky. I'll be right back. Yeah, there's some high cirrus coming and going in that area of the sky right now. So let's see here. Let me move this some more. Oh, there's a good one right there. All right. Let's start guiding on this guy. Looks like my focus is drifting a little bit. Turn this guy on and get a good focus again. Huh. Continue. Let's start on that. Oh, I got it. Well, that happened because I was doing it. All right, this is the asteroid now. Got a good guide star. Focus lock. Says we're good. All right. Let me start the sequence again. Stop this. Resume. Okay. So we're still guiding on a star now. I'm gonna have to do some more research on this for the set points and things like that. I'll have to do some reading on that. But put this over here so we keep an eye on this guy. It's right there. Yeah. So that's moving. All right. Yeah, we're tracking good again. All right. Now this part I've got to read up on here. So if you train it, following the comment for a period of time in the image. Well, I actually put the rates in. And the rates you would just select. Yeah, that's what I did first. Oh, that's what I had to do. Yeah, I'm using the rates that were MPC provides for the asteroid, Brad, and I put them in there, and then some goofy things happened and lost tracking on it. But that's why I'm reading up on PhD right now on how it says to do this. And apparently, I have to I can put the rates in there, but I can also train it by centering on my acquisition camera and just bumping it with the controls from PhD2, so it gets a good solid rate there. Yeah, see, that's what I'm doing. I'm just reading up on this right now because I actually put the rates in, and it looked like it worked for a little while, and then something went bonkers on it. I'm not sure whether I had focus lock turned on, and I think it had a problem with trying to keep the focus, so the guide star kind of bloomed on it, and, and then it stopped tracking well. But this is telling me what I need to do. This is the part I was missing earlier. Let me find a useful enable blah. We'll quickly learn the comet tracking rate as you re-enter this comet. You center it once you have satisfied PhD's tracking. Click stop it in the training. Yep. Okay. Practice the comet tracking using the built-in camera simulator. Oh, okay. All right. Yeah, this is a new thing I was going to try tonight. So, right, you can do that too. I can put the rate in; it'll do that, but you can actually track on it with your main camera, bump it, and PhD will learn what the rate is, and then you turn the assistant off, and it'll track from that point on. The only issue is the guide camera field of view. This field of view of the guide camera, it will use this guide star, and it will track with it and shift each time the rate in RA and DEC that you've just trained it. Eventually, this star will be off of the chip though. So at some point, you won't be able to track it anymore. I think that's what was happening. I was getting down to the limits of the chip there. That's why I think it stopped. But anyways, this is the asteroid right here, and we've already taken, I don't know, 300 frames or something like that. I had 240 of previous frames at 10 seconds, and I'm now taking 480. I've taken another 129 at 5 seconds, and it's been moving significantly every frame. So right now I've got focus lock on. So let's try to keep a focus. Right now it's yellow, which means it's a little out, but just went green. So I'm automatically focusing, and we're still acquiring the asteroid here. I'll put my cursor on it so you can see where it's at. Let's see how much it changes. So I'll have to work with this some more because I like hunting comets. And if I can get this to work reasonably well, PhD to do the correct rate change, at least I could do it where, as long as it stays in the guide camera's chip long enough, it'll work. Once it gets off of there, it'll stop working. As you notice, the asteroid has moved relative to my arrow there, just in the couple of minutes I've been talking. It's moving quite quickly, actually. It's 4/10 of an arc second per second. So the way I've got this set up is I got a laptop out in the observatory running everything, and I'm just remote desktop to it. So I can lose the connection to the laptop, and it'll continue doing what it needs to do. and I'm sitting in my den 150 feet away in a house where it's nice and comfy, and just monitoring what's going on. Oh, I like PhD too. It works. It works really well. Yeah, my cat's sitting here bothering me. I might have to go make myself a cup of coffee. Yeah, PhD too is nice, and it's free. And it works really well, and it works in concert with other apps too. For example, I've told Sequence Generator Pro that PhD2 is my guider, and when I say yep, yeah, I mean all I need is oh, this will just happen to be in my backyard, but I'm actually if I had internet up on my dark sky site, if I had internet, I could do this up there. I'd have to automate the building though first, and so I could open it up remotely and etc. But there's no internet nearby at my place up north. Sky Safari. I can almost see the telescope already in deck position, but not quite. On my on here, let's see, where is it here? There's the RA in deck right there. Actually, these should match. Let me make sure 21. Oh, close enough. Yeah, it's RA is 21 hours, 3 minutes and 25 seconds right now. The deck is minus 55 minutes 37 seconds. I'll type them in here. And the thing is, it's moving, so that's going to change. Yeah, it's 21 03 25 RA and minus 00 55 38. Now, that's where the scope is pointing. That's not exactly where the asteroid is, because the asteroid is a little offset from center of this field of view. But this field of view is what did I say it was 40 by 20, 40 by 23, something like that. So that second number is the deck. That's my current scope position. It's interesting because the data here is different than it is on here. I trust this one more because this is actually off the Gemini. I wonder why that is. This should be reading exactly what this is. I'm not sure why it's not. Oh yeah, it's moving fast. I use the MPC database, the Minor Planet Center, and Actually, let me bring the sky back up here. Oh, where are you? Center it here. And this is the where is it here? It's up here. These are the coordinates I started with, but it's moved. It's actually right here now. So I'm zooming in to give you an idea what my field of view is. Right now, it's actually here, but it was there when I started 2 hours ago. This is where the scope is looking right now. This is where I started, or I'm sorry. Let me see and make sure I don't get confused here. This should be synced with it. Why is that? Hang on a second here. Let me do a find on this again. Find. Yeah, the data's been updated. Now let's center on it. Okay, there we go. So this is my field of view, and you know the asteroid was a little bit off center of my field of view, so that shows that here. So right now, the scope is looking here. The object is actually right there. Okay. My field of view is not centered exactly there. And these coordinates are now 21 hours, 2 minutes, and 12 seconds. And minus 0.57 arc minutes, according to the Sky software. Well, it should be. I've got Sky Safari too, as well, but I haven't looked at it. So neither position is close, huh? That's interesting. I'm not sure I have an answer for you right now. But this guy should be telling me accurately what it's pointing at now, and I think that is correct. And I don't think this number over here is correct. It's within 6 or 7 arc seconds, but I think this is correct where I'm pointing right now. The object is right here, and it's moved a lot actually. Yeah, it must be a problem with the Sky Safari data set. Now, this is where the scope's pointing, but which would be the center of this field of view, or approximately. But as you can see, the asteroid's a little ways away from center. I have 2 monitors here, so I've got the YouTube feed and all the other software I'm running on the other monitor, but this is the monitor you guys see. Well, it's kind of weird. I've had it be accurate. Um, I guess it really depends on where are they getting their data. If they got two places for it, there's something goofy going on. I've been using the Sky software. Well, the copyright on my distribution from Sky Pro 6 was 2005, so I've had it, at least 12 years. I used to have the Sky 4 and then the Sky 5 and then Sky 6 Pro. I just haven't updated the Sky X yet. I don't know if I will. Because what I found was Sky 6 Pro has somebody made an API, which is a kind of a piece of software in between the Sky and the Losmandy G11 Gemini 2 controller that allows the Sky to talk to the G11 Gemini 2 controller using a Gemini.net ASCOM server. So that's why I can still use my Sky software on this Losmandy that I bought last year, which was cool because I didn't have to go and buy, upgrade the Sky yet. Not sure I want to. This works fine. This whole project's worked out really well. I mean, I started ordering stuff, late October, early November, and had it up and running in December. And I've actually gone through a couple of pieces of software for acquisition. I have astrophotography tools, which will run this camera and my Canon camera as well. PhD 2 I got right away. Sequence Generator Pro I decided to get to. I want to eventually be able to run a series of 15 or 20 galaxies in a night while I'm sleeping. But I've been working on trying to figure out how to get the plate solver to work correctly. It works sometimes, but not always. Because I need that to be able to, I need to be able to slew to the object, have it take a photograph, plate solve the photograph, and make the small corrections to center the galaxy, and then start the regular sequence. And the software should let me do that. And then when it's done with the sequence there, slew to the next one, take a shot, plate solve, put it in the center again, and then do the sequence for it. That's where I want to go with this. I want to be able to go across multiple objects in a night without having to center it manually. I want the plate solve to do it for me. Oh yeah, if it's not broke, I'm not going to fix it. So that's why I'm still using the Sky 6. It's okay. It works good. I can use it to, slew to whatever I want. For example, M92 is not very far away from the asteroid right now. You click on that and go image it if I wanted to. So I use the Sky to slew around uh, the scope around to various objects using it, but I can actually in the sequence process, and I have to read up more on it. In the sequence, I supposedly, let me check this here. I have to look up the scripting, but scripting may let me do that where I could pick multiple objects or I can put them in the sequence, but I got to have it allow it to slew. And I haven't figured that out from this yet where it would slew the object. I think it might be right in here. More to learn. That's part of the fun. I lost? No, that's still there. Why isn't that updating? Yep. For some reason I lost the focuser. Don't know why. Is this guy still working? Well, the focuser is still online. And you can set this focus lock up to only change maybe after 10 frames, averages amount, and it makes it, or you can make it very aggressive so it tries to focus on every frame. I decided to back it off so it looks at 10 frames, averages about before it decides to move it. That's another thing. This piece of software is controlling the focuser, which is also a network device in my router. I actually have a router out there who is yeah, I just gravitated to these pieces of software, Brad, and they work. So the focus lock was really important to me because it works with my Optec focuser and PhD2, and I don't have to use. There's actually a temperature sensor on the focuser, but I don't have to use it because I've got this closed loop focusing mechanism that keeps focus. And since the guide camera and the main camera are parfocal, I use this software uses the PhD2 guide. Hello, how come I'm not on a star here? Somehow I lost that. Take a look at this a second here. No, it's not complete. Dismiss. Give this a second here. It decided since the guider wasn't working, it would stop the sequence. We'll let this settle. Take a look at this. That looks a little better. Okay. Anyways, what I was explaining is that this software looks at this guide image and it will keep this focus, which keeps also the main camera focused. So it's a closed loop, real-time updates. And that's why I did it that way. I didn't want to have to deal with characterizing the temperature changes on the scope, since that'll vary from season to season anyways. All of the scope is carbon fiber trusses, but this works really good, and I have no complaints about it. I need to resume this now. Actually, let me pause that. I'll keep that one. I want to see why this didn't connect. There we go. Now we're connected to that. Now I can resume this. Now I can go over here. And the current temperature, there's a temperature sensor on the focus, and it's right now 5.5 degrees. It's a 10-inch F8 RC, Ritchie Gradient from GSO. It's a truss tube. Yeah, you have to kind of update that. Lauren Ball was having the same trouble with Sky Safari. When he posted those numbers, I talked to him privately, and it looked like he admitted that the MPC data from today was much more accurate than what he had a few days ago. So, it's always good to I always update my comet data from the MPC on a regular basis. And in case of this asteroid, I had just downloaded the data today. So it was right on. I flew to it and it was in the field of view. But as you can see, it's moving quite a bit. It's a 10-inch RC from GSO, truss tube. It's on a G11 mount from Los Mondi. I'm running a ZWO ASI 071 MC single shot camera. I usually cool it to 0 degrees. I've got a Lodestar 2 guide camera, and I'm using what's called an on-axis guiding port. Most people don't have that. They use off-axis. I use on-axis, which gives me the entire field of view of the 10-inch available to my guide camera. So I don't have to look at the edge of the field of view. I can go right into the middle of the field of view with it, and it has an XY movement on it, so I can move all around the 10 inches field of view to find a guide star if I need to. Usually I have it anyways. It's a big enough chip. I'm actually thinking of getting a bigger monochrome chip for guiding, so I don't even have to ever move it. I always have a star in there. Almost always I do here. It's rare that I don't. If I do, that's a manual process. I have to move it, translate an X and Y out there on the scope itself, lock it down, and then I'm good to go. Right now it's fairly centered. It's an on-axis from, what's the company's name? Scientific Innovations or something like that, Innovations. They're out of Pennsylvania. It's not cheap, but it has a 90-degree diagonal on it, and it lets near-infrared light straight through to the guide camera, and the white light is bent 90 degrees out to the acquisition camera. So that's how it works. It uses near-infrared for to guide on, and it introduces a little astigmatism on the guide camera on purpose so that it can monitor this shape. So it'll in one axis, if it's inside focus, it'll go long in one axis. If it's outside focus, go long in the other axis. So what the idea is to minimize both axes, and it does that pretty well. And that's what the focus lock uses to determine a focus. You notice it's pretty round here, but if you look at it closely, it's actually kind of diamond shaped. But that's what the focus lock does. Any other questions? Here's our asteroid moving right along. I'm taking a lot of images. I better check my. I never thought to check this. I should check the space I got on this drive here. Oh, I got lots of space. Lots of space. I'm good. Yeah, just look up on-axis guide port, and yeah, I'll do that. I think I could do that from here. I'm not sure my laptop's got network connectivity. Hang on a second. This not off axis. I want the on axis. There we go. Innovations Foresight is what it's called. And it uses focus lock. Does it look familiar? And this is the one I have. That's what it looks like right there. Yeah, I use a dichroic diagonal, full field, full aperture, full field of view. In other words, it's not a pick off on the edge. It's a full sized diagonal, and it lets everything over 7,000 angstroms through to the guide camera, and everything under 7,000 goes to the imaging camera. And that's the smaller on axis. That's the 2-inch. They have a 3-inch as well, which if you had a full frame chip, you'd have to go with the 3-inch, which is like almost twice the money. But I have an APS-C chip on this camera, and it works pretty good. There is a tiny bit of vignetting around the corners, which it's not supposed to have, by the way. In all the discussions I had with Gaston, who's the owner of Innovations, he said you should be full aperture to the camera, but I'm not. I haven't figured that one out yet. Yep, yep. I did a lot of planning on this one before I bought anything. I have not bought any parts that I've not used when I put the system together. I had been planning on someday putting a new imaging system together since I got out of it a while back, and I did plan everything out. I wanted as much automation. I wanted a Ritchie Cradian because I wanted fixed mirrors for not where the mirror shift or anything like that. I wanted a focuser. It was controllable. A cool camera, and I had found that on-axis system. I thought that would be kind of nice to be able to have the full 10-inch field of view available to that camera. So I'm using everything I bought. Planeway and Apergy say that too. Say what? Yeah, but I did it for less, probably a third or a quarter of the price. And the reason I got the 10-inch and the G11 is they were a pretty good match for weight. G11 will hold 60 pounds on the optical side, and the 10-inch only weighs 34 pounds, and I think I have about another 10 pounds of instrumentation on it. Oh yeah, but no vignetting. Okay. Actually, if I'd gotten the 3-inch, the 10-inch that I've got, it's got a full 3-inch aperture coming out of it. But if you don't put a 3-inch focuser on it, which I don't, I have a 2-inch focuser and a 2-inch on axis. Well, if I had gotten a 3-inch focuser, I wouldn't have the vignetting, probably. If I'd done everything for 3-inch, I wouldn't have any vignetting because this chip isn't big enough to cover 50 millimeters. It's only 23 by 17, I think it is. Where did I pull that up? Pull that back up. Where is it? Here it is. Yeah, the chip size is 23 by 6 or 24 by 16 with a 28 millimeter diagonal. So, the vignetting could be because of this. Since I've only got a 50 millimeter path that's about, let me figure this out, be 90, 156 plus another, got 3, that's another 24, right? Yeah, 180, about 197 millimeters from the front edge of the 2-inch focuser to the chip. So it's about, almost 200 millimeters travel from where the 2-inch is at all the way to the chip. And So I'm sure it's because I've got 90 millimeters of a 2-inch focuser. If I'd gone with the 3-inch focuser, I would have had a bigger cone coming in. So it's okay. The vignetting's just in the corners. This is one of the shots I took with this camera in this setup. This is the Fireworks Galaxy. And the supernovas right here. This is about almost 4 hours of exposure on this image right here. I don't know why this Facebook, oh, there must be a Facebook driver running in the background. Keeps giving me these notifications. I don't remember turning it on. Okay, Shannon. Glad you stopped in. Okie doke, Brad. Yeah, I wasn't going to go any long exposure stuff tonight anyway, so I think when this sequence is done, I may call it a night myself. I do have to get up and work tomorrow. Or I might pick something out and let it run while I'm sleeping. We'll see. Anyhow, here's the asteroid still cooking along here. I'm going to step away for a couple minutes. I'll be right back. All right. Oh, there's still somebody here. I wonder who that is. Yeah, we're still running. Excuse me. We're still running here. Meow, meow. Yeah, what do you want, cat? Tracking's pretty good, plus or minus up 1 pixel. Looks like we're running a little bit on the one side there. That's interesting. Could be chasing seeing. That's what I think we're doing. We're chasing seeing. That's what that's. It's hard to get good seeing here in Michigan, since I'm running a guide camera at over 2,000 millimeter focal length. I can look at these. Let me see here. Let me see. Where do I go to do that? No, no. I don't remember. I wanted to go back and look at some previous images. Problem is, it'll be these guys are popping up every 5 seconds. Guider settling. It should. Why are you? It's running on the negative side for some reason. Okay, it popped back up there. Getting a little bit of oscillation in the deck. I wonder if I'm getting some backlash going on there. One of the other experiments I'm going to have to run is the see what kind of periodic error I actually have in this. I haven't figured that out yet, but it's not too much. This thing is still trying to settle. Yep. So I wonder if I may be getting some clouds. We did have some high cirrus out there. Alright, it's taking another image now. There we go. So this thing has moved from about here to here in the time frame that I've been working on this sequence. I have another sequence that's moved about halfway across the field of view. Yes, I will be, Dan. I'll be I'll make a time lapse. There's going to be some jumps in this because of delays and some of the thing, between the sequences. Plus, I was messing around with the tracking setup, and that failed after a little bit. So I'll put it together. There'll be some jumps, but we'll see. Yeah, the comet ones I did came out pretty good, given the sky conditions I had from some nights. I remember one night I was basically shooting through cirrus clouds for 2 hours, and then finally the last hour cleared out and the background sky got nice and dark. But I live in Michigan. You gotta kind of go with what you get. It's we don't get a lot of clear weather here. I don't care what time of year it is. We probably get pretty good skies in September and October, and then it goes to crap from November until March. I get 10 nights from November to March. And actually, what this setup did for me this last winter was usually in the wintertime I won't go out and observe because it'll be too cold, or if I go out it's only for an hour with my 14. What this did was any clear night I could get it started up and do a 4-hour run, sit nice and comfy in my den, and get some nice images. or I can go to bed and get some images and check them in the morning. So this has worked out. I've done more, telescope time in this last 10 months that I've done probably in the previous 3 years. Because my cycle has been observer, astrophotography on film, observer, astrophotography on cheap chips back in the 90s, and then observer for another decade. And now I've gotten back into imaging again. So I have a little experience with imaging. It's just that all the technology has gotten so cheap now. And I'm, coming close to the end of my career. So, and the kids are gone. So I had some money to put down on a new system. So that's why I did it. And it's been fun. Been doing comet work, playing around with some of the nebulous clusters and some galaxies. I've actually been tracking I think I don't know if you saw this, but here's one of my images of the fireworks galaxy with supernova right here. That's something I did over in May, I think it was, in June. And so it's been fun. Been fun doing this stuff again. Gotta close that. Boy, this guide camera's having a little problem tonight. It's not settling. I don't know why. 1.1 arc seconds off. I haven't had it delay this much before. Of course, yeah, I know why it's doing this, because I'm taking such short exposures. It's checking it every time. I'm used to having a 5-minute exposure, and they won't even check the sequence pro won't even check to see if the guiding's nominal or not. The guiding is usually pretty nominal, anyways. So. Dan, I love doing this stuff. Been a techno geek all my career. I'm actually a real-time data acquisition specialist at Ford Motor Company in the IT world. So I built data acquisition control systems, database schemas, data processing software, web-enabled tools for the company. My biggest, longest stint was at the safety lab, so I actually built all the systems they're using to crash cars out there. And so putting this together was pretty straightforward, interesting, but pretty straightforward for me. I knew what I wanted to accomplish. The way I usually attack a problem is I want to be able to do X, Y, or Z. What hardware and or software is out there to allow me to do it? So that's how I approach this one too. I want to be able to do this, this, and this. What hardware and software is out there allows me to do that? I put the portfolio together and ordered parts and put it all together, and it works. And there's always a little tweaking here and there to get stuff the way you want it. So this asteroid has moved past the star now. It started over here when I started this sequence. It's moved quite a bit. If folks have any questions, just let me know. I'm going to probably finish this sequence up and call it a night. See how much time we got left on here. About another 11 minutes here. Plus whatever time it takes for the this autoguider settle in between frames. See, it's bouncing around a little bit. I believe this distance is plus or minus a pixel. It's over here telling me that. I can actually improve that. Go to the autoguider. Make this run a little better. I'll go 1 pixel. There we go. And this should finish up a little quicker. I don't need that to be real accurate for this. Yep, now we're clicking along. A little under 11 minutes to go. Well, let's see. There's 2 people watching. Dan's one of them. I don't know who the other one is. See, it's moved away from that star now. I'll put my cursor on it and you'll be able to see it's moved. Boy, my guider's having all kinds of problems tonight. I wonder if we're getting some, holy cow, they just went out to lunch in the deck here. Oh, I should check something. Where's my meridian? Let's see. I'm only 10 minutes past. I should be good. This guy just went nuts on me here. Jumped out 4 pixels away. Sometimes I think a bat runs into my telescope and jiggles it. All right, it's collecting some more. We're cooking again. Wow, that doesn't seem like it's moving here. I don't know what's going on here. Well, I'll be darned. The sky is moving now, and this comet's staying still. I just saw the field move here. Yep. It's gone into comet tracking mode again. Boy, that's peculiar, because I turned that off, I thought. So this star is moving further away, and this guy is now tracking on the asteroid. I had turned that on earlier, and then it stopped working. Because these 2 stars have popped in the field of view. Yep, the sky is moving now. I wonder. I'm a little perplexed now. It's just, I had thought I had shut that off, but it seems to be tracking on the asteroid now. Because these stars are the ones that are moving. Yep, they're definitely moving. How did I turn that back on? This is very strange. That means this has got to be moving too. Because the asteroid is staying fixed in this position on the primary camera, and the sky is moving on me. Yep, yes indeed it is. Interesting. How did I turn that on? What did I do here? I went over here and I did what? Well, I changed the settle time. Oh, I hit this resume button. I must have resumed the comet tracking rate. And that's what's going on now. I didn't realize that. Interesting. Hmm. I must have paused that an hour ago when we were having problems with it. You learn something new every day. Interesting. This is going to make for an interesting time lapse. I'm going to have segments where the asteroid's moving, and then I'm going to have segments where the sky is moving. Well. Yep, that's definitely what's going on. These two came into the field of view a little while after I hit that resume button. Now the sky is moving. We are tracking on the asteroid right now. That's pretty exciting. I think I'm going to do something here. I'm going to add some time to it. See how long I can keep that tracking on the asteroid itself. I just added another 60 frames to the sequence. The only thing I got to be careful about is I'm an hour and 42 minutes to my limit on the west side. It should be okay. It should be okay. I'm only 16 minutes past the meridian right now. And since it's tracking on the comet or the asteroid now, the RA and DEC are slowly moving as well. So anyways, this guy is staying fixed. That's the asteroid, and the sky is moving below it because I'm tracking on it now. I had set that the rate of change in RA and DEC, an hour or so ago, and it was working for a while. Then we ran into a problem where the star went out of the field of view of the guider, focuser went berserk, so I had to shut it down. I think that's when I paused the asteroid tracking or the comet tracking rate, and so I went back to just tracking on the on a star. And then when I hit this resume, it still had this data in PhD2, for the comet tracking. And now it's running at that rate now. So this guy should be slowly creeping across the field of view of this guide camera. I think it is. I think it was up here when I started it. That's why we're tracking. This is good though. This is it was the first time first time I've tried this method, and I'm still in the learning curve on it, but actually got it to work at least part of the time. Let me see how many files I've taken here. Let's see here. Oh, I'm on September 1st now. Let me see how many I got here. 576 images there, and another 82 here, so over 600 images I've taken so far. And the first 480 were 10-second shots. These things are huge. 31 megabytes a piece. So I'm eating up some disk space. But I got plenty left. This is actually how I wanted to do the time lapse, where we could track on the asteroid. That way I don't have to move the scope at all. I had to move it once already because we tracked across almost the entire field, or at least half the field. Let's see what this is at. And it's doing its job. This is great. I didn't realize I had paused and that was part of the problem. Oh. Won't be the smoothest time lapse, but I'll put multiple segments together and we'll see what it looks like. I've got this image stretched so that we can see it. This is the full dynamic range. So when I go in, I'm going to have to do some processing on this thing, on all those images. I'll have to do them in bulk. I stretch it enough so that when the video plays, you can see the stars in it. That'll take some time to do. But I won't do that until this weekend, probably. Maybe tomorrow night after I get back from work. So there's the asteroid, and the sky's moving underneath it each time I do a frame here. So I'll point at one of these stars. You'll be able to see that the star field is moving. The asteroid is staying fixed right now. It's hauling butt. I mean, that field of view is moving quick. This motion, the motion we're seeing in the stars is every 5 seconds or so. And the asteroid's moving quite quickly. I was surprised how quick it was moving. It was a lot faster than the comets I took earlier this year. So I'm gonna let this we'll finish this sequence up, and then I'm done for the night. I'm gonna warm up the camera when the sequence finishes, and we're gonna park the scope when the sequence finishes. Okay. So in about 6 minutes, the camera will start warming up. The scope will go park itself. I can go out there and roll the roof closed, and then I can go to bed. It's 12:30, 12:23 here, and I have to get up for work in the morning. I'd love to do this all night, but I am not retired yet. Oh, getting a satellite through. Almost done. Now I'm going to call it a night, guys. It's finishing up its last one here. Sequence is done. Dismiss. Close. Okay. Trying to think how close I was to the park position. Should be. Let me see. Interesting. I'm going to have to go out and see what that looks like now. Okay, folks, I'm done.